everyone, this is Miss Leia, and in this video, we're going to talk about image formation in mirrors. So for our learning targets, we have to be able to differentiate the types of waves according to medium, describe the concept of electromagnetic spectrum, and lastly, explain the significance of light in image formation. Now, the first thing we're going to do is to categorize waves according to medium. The first one is we have the mechanical waves that require a medium to travel through or propagate. And best example would be sound waves because you probably learned before from junior high school physics that sound waves can spread in space because the vibration gets transferred from one particle of matter to another particle. And that's how sound waves work. Same for springs and ropes, they also require matter or any physical entity for them to spread out in space. The second one is electromagnetic waves, which do not require a medium to travel through. So some of the examples are radio waves, visible light, and X-rays. They can do that. They can travel in space even without matter because they're made up of magnetic fields and electric fields that are vibrating in space. And those things are capable of propagating even without matter. We're not going to expound why it happens as such because that's more of an electromagnetism topic rather than optics, but at least for now, that's what you have to know. So these electromagnetic waves can travel even when there's no matter in between. As further information, we have what we call as the electromagnetic spectrum, and it shows us an array of electromagnetic waves that are arranged according to wavelength. So these electromagnetic waves are radio waves, microwaves, infrared, ultraviolet, X-rays, and then gamma rays. And there's something in the middle. It's in between infrared and ultraviolet. We actually have what we call as the visible light spectrum. Now, all of the things we see here, radio waves up to gamma rays, these are all electromagnetic waves. They can all penetrate in space without any medium. Let's say, for example, the EM waves from the sun, despite the vacuum between the sun and the earth, those light waves can reach the earth because it's an electromagnetic wave. So these things, they all have their own functions, and all I'd like you to know is that visible light is not the only form of electromagnetic wave. Those things, radio waves, etc., up to gamma rays, they are all invisible forms of electromagnetic waves. But the one in the middle, the visible light spectrum, that's the one that we're going to focus on because we're talking about image formation. So what exactly is the role of light or visible light when it comes to sight? It's pretty simple. Without light, there would be no sight. Example, a person can see this apple because there has to be a light source. Let's say there's the sun, for example. It can send out light rays towards the apple, and those light rays will bounce off in all directions, and those that will hit your eyes will enable you to see the apple. So I'd like you to think of it as some sort of messengers. I'd like you to think of light waves or light rays as messengers or signal transmitters that as they get emanated from the sun, as those light rays leave the sun and head towards the apple, they will get some information as they interact with the particles of the apple. And once they get reflected in various directions, when they hit your eye, they will send a message to your eye and eventually to your brain that this is how the apple looks like, this is what the color of the apple is, etc. So I'd like you to think of light waves as messengers or signal transmitters. Of course, we won't go beyond the technicalities of that, but basically, everything that we see, it has something to do with the interaction between light and matter. So it's the role of light when it comes to sight. Without light, there would be no sight. Now, the objects that we can see are categorized as either luminous objects. Luminous objects are those that are capable of generating their own light. Best example would be the sun, right? Because there are nuclear fusions happening in the sun's core, and as a result, it generates tremendous amount of energy in the form of light energy, mostly, right? And then we also have what we call as illuminated objects. These are objects that are capable of reflecting light to our eyes. Example would be the moon, because we all know that the moon, as a natural satellite, it's merely a rocky astronomical body. It's not capable of nuclear fusion. It's not capable of generating its own light. What it does is that the light rays coming from the sun can hit its surface, and they will be reflected in various directions. And those that make it past the Earth's atmosphere, they can reach our eyes and eventually allow us to see the moon itself during at night, right? Apart from the sun, for example, of course, luminous objects could also be artificial lighting. Let's say, for example, fluorescent lamp, LED bulbs. Well, for illuminated objects, basically, maybe everything else around you at this very moment, those are illuminated objects. Chair, table, bed, the door, example. So those are the examples of illuminated objects. Just a further example, in this particular room, we have this LED bulb, and this is obviously a luminous object, right? Because it generates its own light. It does not depend on some external source of light ray. So it has a battery, it enables it to generate light energy of its own. But the things in the background, they are just illuminated objects. The piano, the wall, this table, this chest drawer, those are illuminated objects because they simply depend on the light source in this room, is specifically the one in the ceiling. It's the one that makes them visible to us. So those light rays from the light source in the ceiling hit those things, and those light rays get reflected by these things, eventually hitting the camera lens, which makes these things visible to us as viewers. Now, of course, we would expect that if we turn off the light in the ceiling of this room, the only thing that will be visible would be the LED bulbs because these bulbs are luminous. So they generate their own light. Even if you turn off the light in the ceiling, we could still see them. But we can see now that we don't see the chest drawer, the wall, and the digital piano in the background anymore because those are illuminated objects. They simply depend on the light source in the room for them to be visible. Okay. However, you can actually turn this LED bulb in the other direction, like that. And in such case, of course, those light rays will be hitting the piano, the wall, the chest drawer, and they will be reflecting those light rays in different directions. And that sends information to the camera lens or to my eye as I tape this live. And those light rays being reflected by those things, once they hit my eyes, my brain will interpret them eventually as these images. I would see, oh, this is how the piano looks like, this is how the chest drawer looks like. But you might notice it's a bit fainter than usual, right? Because of course the power rating of these small LED light bulbs would be more limited compared to the one in the ceiling. So we don't see them as clearly as we saw them earlier when the ceiling lights were on. Furthermore, if you completely shut down or the remaining light source, which is these LED bulbs, expectedly, we're not going to be able to see anything anymore. So the luminous object, the LED light bulbs, are no longer luminous because we have turned it off, the battery is off. So everything else will depend on any other light source. But since there is no light source that's on in this case, everything will be invisible for us. Okay, so in short, darkness is actually the absence of light. Light. You've probably heard it from some other source that darkness is the absence of light, but what does it really mean? Example, this man, imagine that the door is still closed. If it's still shut, if the door is still shut and the man is in a dark room, he's not, he's literally not going to see anything, right? Because it's really dark, there's no light. So there are no light rays hitting his eyes to send him some information that this is the color of the wall or something. When he opens the door and there's a well-lit area outside of this dark room, we don't see any darkness dissipating towards the well-lit room, right? I mean, you don't see darkness spreading outwards towards the well-lit room, okay? But what we see is the other way around. We can see the light rays from the well-lit area entering the dark room, right? Because there's no such thing as particles of darkness that can sort of spread in some other regions where there is less darkness. But we have what we call as photons or light particles. And these light particles is what make this possible. It's what make this particular scenario possible, that there's a well-lit room and the light rays in that particular area can enter the dark room. But the other way around cannot happen. There's no such thing as particles of darkness that can escape this dark room and make their way towards the well-lit area. So darkness is simply the absence of light, right? And I think that maybe during the times that you consider you are at the darkest days of your life, maybe It's also because sometimes we fail to look at the light in our life. What I mean is that maybe we take some things for granted. Maybe there are some people who are trying to give us unconditional love, but we take them for granted. Maybe there are some things that we aren't grateful for, even if we should be grateful for them. We just look at the dark side. So I think that we really have to look at the light during the darkest days in our lives, right? So whenever there's darkness in your life, whatever form it may take, I hope that you can find some light somewhere. That's all for this video. Have a great day.